Good evening, everyone. I am Dr. Pooja, and all of you know that I've been discussing the biochemistry portion with you guys. Now, finally, the date of AIMS exam have been announced. It is going to be conducted on 29th of November. So this is a high time to get up. Very a little, just 2 months are left to prepare for the exam, isn't it? So what I'm going to do is I just that day before also I recorded one video and I told you guys that best is always prepare subtopics because it's not possible also to revise biochemistry in one go. So what I have done is I have divided my subject into very small modules because I know it becomes very monotonous when you teach also on this channel for 1 hour, and it's very difficult to retain also whatever has been taught to you for 1 hour. So what I will be doing is I will be recording my videos, just small videos, 15 to 20 minutes, and I will be discussing only those questions, only those topics on which the questions have been asked so far. And my advice for all of you would be, whenever you are attending my lecture, whenever you are listening to YouTube, best is always keep a pen and a diary with you. This is very important because nowadays what you people are doing is, I know that students have a habit of watching YouTube, just lying down and just putting the earphones and just listening to that as if they are going to watch some movie. This is not the way to prepare for the exam. Best is always try to make notes, and the thing which is already you have jotted down in your notebooks, I can assure you that you cannot forget that. Right. So this is my advice to you as a, you can say, senior or as a mentor. Okay. So whenever you are watching my videos, always keep a diary and a pen. Very, very important. Right. Now, let's switch over to the content. Now, day before I had started up with the enzymes, I just gave you a brief introduction just to acclimatize what I'm going to teach you also. Today, again, I'm going to discuss a very important topic from examination point of view. And again, I am telling you, I am emphasizing on those particular points on which the questions have been asked. So today, my topic of discussion would be enzyme inhibition. Right. Enzyme inhibition. Now, first of all, you should understand what do you mean by the term inhibition. Inhibition means the act of stopping, isn't it? Because in my previous lecture, I told you enzymes are the biocatalyst which combine with the substrate to form a enzyme substrate complex which dissociates to form the enzyme and the product. And if we see the structure of enzyme has this type of structure where this substrate binds, forming a enzyme substrate complex, releasing the enzyme and the product. Now, inhibition means it is stopping, means it is either stopping the formation of enzyme substrate complex or it is blocking the active site of the enzyme. Right. So broadly, if we have to classify inhibition, it is of three main types: competitive, non-competitive, and uncompetitive. So there are three types of inhibition. Basically, there are other types also, like allosteric inhibition is there, which is a very, very important mode of inhibition. But allosteric inhibition is a very vast topic, and I'm going to take a particular lecture on this. Here, we are going to discuss just the comparative, or you can say the differences between these three inhibition. So let's take up these inhibitions one by one, then I'll show you a comparative table. Now, competitive. See, it is clear from the word there is a competition. isn't it? Competition किसके बीच में है? Between the substrate and the inhibitor. Right. So if there is a competition between the substrate and inhibitor, that means this inhibitor resembles substrate in structure. जैसे the enzyme is like a lock and key, I mean like hypothesis. जैसे every lock is opened by its own key. Same is the case with enzyme. Every enzyme has a specific substrate which is going to bind to the active site. But suppose if we have to write the equation in competitive inhibition, this inhibitor, since it is resembling the substrate in structure, it is going to bind with the enzyme. Right. So if the inhibitor is binding with the enzyme, there would be formation of enzyme inhibitor complex. Now the question arises because more often we talk about the kinetics of enzyme, isn't it? And kinetics of enzyme money, how an enzyme is interacting with the substrate and what is actually happening when this enzyme is binding with the substrate. So there are actually two parameters when we discuss the kinetics of enzyme. One is Vmax and another is K. Vmax is, as the name says, maximum velocity, and Km is the Michaelis-Menten constant, which depicts the affinity of the enzyme with the substrate, and it is inversely proportional. So if I say if an enzyme has high Km, that means affinity of the enzyme with the substrate would be low, and vice versa. If it has low Km, automatically it would be high. And Vmax is the maximum velocity when the reaction has accomplished. Now let's go back to the equation. Equation में you can see कि inhibitor is binding with the enzyme so that the substrate is not binding because the inhibitor is resembling the substrate ring structure. But if we increase the concentration of the substrate, then there won't be any binding of the inhibitor. That is why we say this competitive inhibition is also known as a reversible inhibition. Now see, what happens is whether the substrate is binding, whether the inhibitor is binding, so there won't be any change in Vmax. So Vmax would be same. But if we talk about Km, Km would automatically decrease or increase. Now you tell me, dekho, it is depicting the affinity of the enzyme with the substrate. If inhibitor is resembling the substrate in structure, affinity would automatically decrease. Up, if affinity is decreasing, that means Km will increase. This is how you have to remember. So if we talk about competitive inhibition, since there is a competition between the inhibitor and the substrate, there will be same Vmax, but Km will increase. And the equation would be this. Examples of competitive inhibition we are going to take in detail in our next video. As I told you that I am going to move slowly, and I will see each and every aspect of biochemistry is, completed in my videos. Then we come over to the next type, which is non-competitive inhibition. Non-competitive inhibition. Now you see non-competitive, no competition. See, it's very easy to understand. Whatever is the written in there, it has its own meaning. If there is no competition between the enzyme and the substrate and the inhibitor, the equation here would be this: ki inhibitor can bind here and inhibitor can bind here, right? Now, if you look at the aspect in non-competitive inhibition, what will happen to Vmax and what will happen to Km? Up since there is no competition, if we take this aspect like, so what happens here is substrate is binding here and the inhibitor is binding here. So there will be a change in the conformation. And if there is change in the conformation, Vmax will automatically decrease. Because you can see inhibitor is binding with the enzyme substrate complex. So conformational changes there, Vmax will decrease, but Km will remain the same. Totally different from what was happening in competitive inhibition. Competitive mein Vmax was same and Km increases, but here in non-competitive inhibition, Vmax decreases and Km remains the same. So this is non-competitive inhibition. I am going to take these inhibitions in detail with examples tomorrow. Abhi just so just try to remember these important points. Then finally, the last inhibition is uncompetitive inhibition. Ab uncompetitive, it is very rare first of all. And here, one very important thing about this is the inhibitor binds. I'll write it here. This inhibitor binds only with enzyme substrate complex. And this is the difference, point of differentiation between uncompetitive inhibition with the rest of the inhibition. So it is like this, enzyme plus substrate forming enzyme substrate complex which dissociates to form enzyme and the product. So in uncompetitive, it will bind here like this, resulting into two things. Vmax will decrease. Similarly, Km will also decrease. Even though uncompetitive inhibition is very rare, but it is there. So overall, if we see, inhibition is of three types: competitive, non-competitive, and uncompetitive. Now, if I have to differentiate on the basis of the table, because these are the questions which have been asked in the exam, and always remember, every year a question comes. So agar hum baat kare, if we talk about Km, in competitive inhibition, it will increase. In non-competitive inhibition, it will remain the same, but in uncompetitive inhibition, it will decrease. Second mode of parameter is Vmax. If we talk about Vmax, in competitive inhibition, it will be same. In non-competitive inhibition, Km will, Vmax will decrease here, because just now I told you, but in non-competitive, what I am doing, just a sec. Yes, we are talking about Km first. Competitive may it will increase, non-competitive may Km remains same, and in uncompetitive it decreases. Vmax in competitive, yes, it is same. It will be same. In non-competitive inhibition, it will decrease, and in uncompetitive inhibition, it will decrease. So this is how we correlate three different type of inhibition, right? If you have any problem, you can log into my website. My website is Biochemistry simplified.com. Basically, I am here to make biochemistry simple in a layman's language. That is why my channel is Biochemistry Made Easy also. Right. So today, in today's video, we discuss the different type of inhibition. Tomorrow, I am going to discuss examples of these type of inhibition. So in this today's video, the major highlight which you should remember is the difference between Km and Vmax in 3 different type of inhibition. So I hope these 3 different type of inhibitions are clear to you in reference to Km and Vmax. So tomorrow we are going to discuss what are the therapeutic use of competitive inhibitors, what is the difference between competitive and uncompetitive, with references, with examples from the different metabolic reactions. So see you all tomorrow. Good night. Take care.